be looking out in case I make any algebraic mistakes or something, or you have any questions.
Okay, that sounds good.
But we should be fine, and after we do it, I'll probably want to go over it again just to make sure I didn't make a mistake anywhere.
Okay.
So it'll be like a polynomial. It'll probably be something like the integral. Let's do 2x squared minus 2x plus 5. Alright, so honestly, what I would recommend is, depending on how good you are at your integration skills as of right now, I would just go ahead and take the integral first, honestly, so you know what answer you're looking for
Okay.
whenever you're doing the Riemann sum. Does that make sense?
Yes.
Yeah, so let's just go ahead and integrate, and let me think of bounds. Let's do this from 1 to 3. Alright, so let's integrate this. So we can, do you want me to split it up?
It's okay if you don't split it up.
I'm sorry, you cut out.
Oh,
What did you
sorry.
say?
I'm okay. You don't have to split it up. I kind of I understand like how we
Okay.
do it. But thank you, Sarah.
Okay, that's good. Alright, so just taking the antiderivative, we're going to get, so we have 3, so it's going to be 2/3 x cubed minus 2 over 2x squared plus 5x, evaluated from 1 to 3. Obviously those 2's are going to cancel out. And then we just plug in our 3 and our 1. So in our first parentheses, we're going to have 2/3 3 cubed minus 3 squared plus 5 times 3. That's all going to be minusing 2/3 times 1 minus 1 squared plus 5 times 1, which is just going to be 5. So that 3 on the bottom is going to cancel out with one of those powers of 3, so we just have a 3 squared. So 3 squared is 9, and we multiply that by 2 to get 18. And then 3 squared is 9, plus 5 times 3 is 15. And then inside our second parentheses, we have 2/3, and then we have a -1 and a +5. So that's just going to be plus 4. And let's go ahead and rewrite that for, I guess let's just do it this way. We can just distribute that negative to both of them in our next line, and then we're going to add all of that together in the first bracket. So 18 minus 9 is 9, and then plus 15 is going to be 24, and then minus 2/3 plus 4.
It wouldn't be -4?
Oh, yeah, sorry.
Okay.
Minus 4.
It's okay.
Yeah.
I was putting.
Sorry, I was looking at that.
Yeah, I was
I
putting
was
it
like,
the
I did
add
something
too.
wrong. Yeah. I even said distribute it, and I just
Yeah.
didn't do it for whatever reason.
It's okay.
And then we're going to end up with 20 minus 2/3. You can either plug that in your calculator or find common denominator. We just have to multiply that 20 by 3 over 3. 20 times 3 is 60 over 3. Minus 2/3 is going to be 58 divided by 3. And that is not divisible by 3. So that would be, we're looking for this answer, 58 divided by 3.
Okay, I got that
Whenever
too.
we do this sum. Okay. So now we can actually start doing this integration. So I'm just going to go ahead and move that integral down so I don't have to rewrite it.
What is this called again?
what we just used to like apply these.
Yes.
It's what we're using the fundamental theorem of calculus
Mhm.
part 2.
Okay, so that.
Um, yeah, and all it means is that when you have an integral from a to b f of x dx, it's going to be equal to f of x evaluated at the a and the b,
Okay.
and then that's equal to f of b minus f of a.
Okay.
So yeah, this is important to know.
Okay. Thank you.
No problem. All right, so now we can actually do our summation. And I am going to write down the formula for that.
Oh.
So whenever you have our integral, so I'm going to just rewrite this integral. I don't know why I put that equal sign there. 2x squared minus 2x plus 5 dx. And then we're going to get the limits as n goes to infinity. And then we have our b minus a over n. Our b is 3, and then our a is 1. So we're going to get 3 minus 1 over n times that summation symbol from k equals 1 to n. And then on the inside, we are going to have our function evaluated at, let me write it up here. It was our function of a plus k over n times b minus a. So since our a is 1, we can plug 1 in right there, plus k over n, and then times 3 minus 1. All right. I'm not sure why I did it in blue there, but 2x plus 5. All right, so just simplifying that, we see that's going to be the limit as n goes to infinity, and then the first part simplifies to 2 over n, and then the inside of that function is going to simplify to 1 plus 2k over n.
Will the limit h to infinity always be like that, or will it be changed?
Are you talking about this part right here? The limit?
Yeah, the limit.
Like, will that always be n to the infinity?
Yeah.
Yeah, when you do this Riemann sum, I mean, there are other versions, like, you know, the one that he said you didn't have to memorize, I think, in the email, but the one on the memorization, how it's a little different, it has that limit of, like, the norm of p to the cube, you know, so that's just a different way to write a Riemann sum, but whenever you're doing this problem, you're going to use this form of a Riemann sum.
Oh, okay.
Does that make sense?
Yes. Thank you.
And also, hey Sophie, we're doing a Riemann sum practice problem. I didn't see you join, so I'm not sure how long you've been in here.
Hi, I've only been here for like 5-4 minutes, something like that.
Okay. We just started doing a practice Riemann sum problem. What are you here for today?
I had a few questions, just like small questions on some of the problems from the practice exam. And then I have one more question on a previous exam I took that I failed, so that I wanted to go over.
Yeah.
But that's basically it.
Okay. So what I'm going to do is, I feel like we're at a good point, right? And then from here, you know that we have to plug in this into our function, right? Our 1 plus 2k over n into this 2x squared minus 2x plus 5. Does that make sense, Stephanie?
Yes.
So, because I mean, you can work on this by yourself,
Mm-hmm.
and I mean, I'll go over it with you. I just want to touch on at least some of the stuff that Sophie has, so I can
Mhm.
like go in between. Does that make sense?
Yes.
Are you okay with that?
Yeah, I'm fine with that.
Awesome. All right, but we will do that together after you try it. And if you get stuck, just let me know.
Okay. Okay.
All right. Sophie, what do you want to do first?